warahmatullahi wabarakatuh, and very good morning to our lecturer and my friends. Today I will present about today we will present the assignment fluid of mechanics. The title is pressure in pipe. Before we start, let me introduce our team's member. First, myself, Nurul Fatih Akmal binti Muhammad Zain. Next, Muhammad Akil Aiman bin Abdul Manap, Muhammad Khairul Adha bin Roslan, Muhammad Syahul Ikman bin Jastiman, and last Muhammad Syafiq bin Muhammad Sharif. Okay, so we move to the next slide about introduction. We have conducted an actual experiment to study the types of fertigation configuration system by using daily life equipment. We set up the experiment to study this application system, then compare with the computer simulation data. For objective, to perform experimental and simulation flow exercise in hose pipe. For main goal, to analyze the pressure variation in hose pipe over a specific pipe length with two different configuration, and last, to analyze Bernoulli equation.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq bin Muhammad Sharif. My metric number is B0920103339. Today, I would like to present the procedure for this experiment. For the straight pipe, first, we need to cut the 10-meter hose pipe into 6 meter long. Second, make 6 holes at the hose pipe. Third, put the 6 nozzle for each hole at the hose pipe. 4. Put some glue on the hole where the nozzle is placed to make sure there is no leaking on the hose pipe, and wait for it to dry. 5. Connect the hose pipe through single connector to the water supply and tighten it using hose clip. And lastly, open the water supply and take the time flow rate 200 ml water for each nozzle. Next, the looping pipe. For the looping pipe, first we need to cut the 10-meter hose pipe into 6 meter long. Second, make 6 holes at the hose pipe. Third, put 6 nozzles for each hole at the hose pipe. Fourth, put some glue on the hole where the nozzle is placed to make sure there is no leaking on the hose pipe, and wait for it to dry. Fifth, connect both end parts of hose pipe into the T-connector. Sixth, connect the other side of T-connector to the water supply. 7. Tighten all connection from hose pipe at the T-connector using hose clip. And the lastly is open the water supply and take the time flow rate 200 ml water for each nozzle.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Khairul Adha bin Roslan, and I'm going to explain the experiment 1. Experiment 1 is we need to calculate the flow rate, velocity, and maximum pressure in pipe for water that came out directly from water supply. So the rho is 1000 kg per meter cube. The diameter is 0.019 meter and radius is 0.0095 meter. For the area, we use the area equal to pi r squared, and we got the area equal to 2.835 times with 10 power of -4 meter square. And after that, we're going to calculate the flow rate. Flow rate equal to V divided by T, and we get the flow rate equal to 1.46 times with 10 power of -4 meter cube per second. Then after that, we're going to calculate the velocity, which is velocity equal to Q over A, and velocity equal to 1.46 times with 10 power of -4 divided by 2.835 times with 10 power of -4, and we get the velocity equal to 0.515 meter per second. After that, we're going to calculate the maximum pressure in pipe. We use the formula P1 equal to P2 divided by rho G plus Z2 and times with rho G. Then we get the P1 equal to 111.83 kilopascal. Experiment 2, we're going to calculate the open loop pipe. The cross-sectional area equal to pi r squared and area equal to 4.536 times with 10 power of -5 meter squared. For the flow rate equation, we use the Q equal to V over T, and velocity equation, we use U equal to Q over A. This is the time taken for filling the volume of 200 ml for hole 1 until hole 6. And this is the sample calculation to get the flow rate and velocity. For the volume equal to 0.0002 meter cube, and diameter nozzle equal to 7.6 mm, and the area of nozzle equal to 4.536 times with 10 power of -5 meter squared. For the volume flow rate, Q equal to V over T, and Q equal to 0.0002 over with 3.37, and we get the volume flow rate Q equal to 5.935 times with 10 power of -5 meter cube per second. Then we calculate the velocity U equal to Q over A. Then U equal to 5.935 times with 10 power of -5 divided by 4 over 4.536 times with 10 power of -5. Then we get the final answer is U equal to 1.308 meter per second. This is the final data for flow rate and velocity for hole 1 until hole 6.
For experiment 3, we do closed loop pipe. The data for experiment 3, our volume is 0.0002 meter cubic, and diameter of nozzle or hole is 0.0076 meter, and the area is 4.536 times 10 power of -5 meter square. For hole number 1, the time taken is 4.7 seconds. Number 2, 4.89. Hole number 3 is 7.82. Hole number 4 is 4.40 seconds. And number 5, 4.52. And last, hole number 6 is 4.9 seconds. We use nozzle number 1 for sample calculation to get flow rate and velocity. For volume flow rate, the equation is Q equal to V divided by T. So 0.0002 divided by 4.70, and we get 4.255 times 10 power of -5. And for velocity, the equation is U equal to Q divided by A. So 4.255 times 10 power of -5 divided by 4.536 times 10 power of -5, and we get 0.938. And this is the final data for experiment 3 from hole number 1 until hole number 6. And the data we take for time taken, flow rate and velocity. So unit for flow rate is meter cubic per second, and for velocity, the unit is meter per second.
So today I will explain how I did run the simulation in MSys. From the simulation, we can come up with 3 contour results, and for the straight pipe simulation is total pressure. The minimum of total pressure is 111,800 829. The maximum of pressure is 114,935.8. Second is Reynolds number. The maximum of Reynolds number for straight pipe is 321.0681. And the last control is velocity. Our velocity for straight pipe is 2.44377 meter per second. And the last picture shows how we mesh our straight pipe. Okay, next is our loop pipe. The total pressure in loop pipe is the minimum is 111,839, and the maximum of pressure is 112,223.9. Second contour is Reynolds number. The Reynolds number is 108.06, and the last contour is velocity 0.849 meter per second, lower than straight pipe. And this is our last mesh of loop pipe picture. And as you can see, the inlet is blue color arrow, and the red arrow to the top means the water is going to the top in our hose we made.
As we can see that this experiment also we use the ANSYS, that also we learn how to use this animation to make this experiment development, and this can make someone or others team can more knowledge about this. Next, what we learn during lab, we apply on doing this experiment. This experiment be able to apply several concepts of the Reynolds number, which is to determine the fluid of weather such as laminar or turbulent. That's all. Thank you.
Hello, good evening. So today we will show how we conduct our fluid mechanics assignment. So as you can see, we measure the hose pipe 6 meter, and we make a 6 hole. So right now, my team will open the power water supply.
Right now, we're going to measure the flow rate of water for each hole, which is 6 holes, by record the time. We're going to record how long it's going to take to fill this 200 milliliter of water. So we're going to record the time for water to fill up this 200 milliliter of water for each hole. So, Shafiq.
Okay, right now we're going to measure the water flow rate for looping.